Hi again. We will continue on the overview of turbine. So on the previous video, we have looked into the basic principle of the turbine. To continue with, for a given output, the gas velocities, deflections, and hand losses are reduced in proportion to the square of high mean blade speed. So it is interrelated. The output of the gas velocity deflections as well as the losses are reduced in proportion to the square of the high mean blade speeds. So the stress in the turbine disc increases as the square of the speed. So it is as the speed increases, so the speed increases, the stress of the turbine disc also increases. Therefore, to maintain the same stress level at higher speed, the sectional thickness, hence the weight must be increased disproportionately. So for this reason, the final design is compromised between both the efficiency as well as the weight. So whenever you want to design, you have to look into the aspect of the balance between the efficiency of the turbine disc as well as the overall weight. The engines operating at higher turbine inlet temperature, so normally known as the TIT, okay, are thermally more efficient and have an improved power to weight ratio. Bypass engine have a better propulsion efficiency and thus can have a smaller turbine for a given thrust. So if you look at the engine that has high bypass ratio, you have a smaller section of the turbine compared to a gas turbine engine that has no bypass, normally the military type of engine. Now, the design of the nozzle guide vane and turbine blade passages is based broadly on the aerodynamic considerations and to obtain the optimum efficiency compatible with the compressor and combustion design, the nozzle guide vanes and turbine blades are of a basic airfoil shape. Later we will look at the how does the nozzle guide vane looks like. So in terms of the types of turbine, we have looked at the combustion chamber, we have looked at different types of compressor. So now the turbine also have different types. So the first one is impulse type of turbine, and then we also have reaction type of turbine and a combination of impulse and reaction type of turbine. The first one, impulse type. How does it look like? So the total pressure drop across each stage of turbine occurs in the fixed nozzle guide vanes because of their convergent shape. Increase the gas velocity whilst reducing the pressure. So the gas is normally directed onto the turbine blades which experience an impulse force caused by the impact of the gas on the blade. So you can, for impulse type of blade, you will have gas being directed or impacted on the blades directly. For the reaction type of turbine, the fixed nozzle guide vanes are designed to alter the gas flow direction. So the gas flow are being directed into a certain direction without changing the pressure. The converging blade passages experience a reaction force resulting from the expansion and acceleration of the gas. So it is slightly different compared to the impulse type of turbine. Okay, before we go further, the figure here is a comparison between the pure impulse turbine and impulse reaction turbine, the combination of impulse and reaction turbine. If you look here, Normally, gas turbine engine do not use pure impulse. Normally, we do not have just pure impulse or pure reaction turbine blades. But normally, we have a combination, which is a impulse reaction combination for gas turbine engine. Okay, so over here, you can see here turbine driven by impulse of the gas flow only. So this is nozzle guide vane, the NGV, right? So the gas will impacted on the turbine and it will turn the turbine. So this is called the impulse turbine. Whereas for the other type, the turbine driven by the impulse of the gas flow and its subsequent reaction is accelerates through the converging passage blade. So a combination of the impulse and turbine is being highlighted here. So you have the impulse as well as the reaction of the turbine. So the proportion of each principle incorporated in the design of a turbine is largely dependent on the type of engine in which turbine is operated. So, but in general, about 50% impulse and 50% reaction. And impulse type turbines are used for cartridge as well as the air starters. We will continue to look into more detailed aspect of turbine in terms of the energy transfer from gas flow to the turbine in the next video. Thank you very much. Bye bye for now.